we have here the definition of how we're going to use what is the benefits of knowing the bypass factor. So bypass factor, it is defined as the inability of a coil to cool or heat the air to its temperature, so indicated by a bypass factor. So we have here a coil with low bypass factor has better performance. So as much as possible, we try to lessen the we have to get a lesser bypass factor. So that defines that one. So we have here the equation for the bypass factor. So that is 1 minus the cooling contact factor, where 1 minus the value what we have, that is 0.82, 0.82, that is 0.82 is equal to, so we have the value of 0.18. Okay, so this is less, so it means that our coil have a good efficiency. So that defines that one. So another equation that we can use for computing the contact factor is by using the change in humidity from 1 to 2, and you have your initial humidity and you have your 4 to 3. So also the same, also we have your enthalpy. Or for the bypass factor, we can also use this equation. We have the change in humidity. So this is humidity T3, sorry, and the change in also of enthalpies and the change in also of the temperature. So it's another way of computing the bypass factor. Now calculating the cooling load. So we have your equation again. So that will be the mass flow rate times the change in enthalpy 1 to 2. So let's find what's the value of enthalpy first of this enthalpy 1, enthalpy 2. Okay, so at point 1, we have the enthalpy. So this is our point 1. So let's draw the straight line here. So we can able to determine what will be the value of your enthalpy. Okay, so we have around, that is 61.5. so we can put it here. Your enthalpy is 61.5, so this will be kilojoule per kilogram for this part. Okay, and also for the specific volume, since this is the line for the specific volume. Okay, so we can also draw the line here. So parallel, no? So we have a parallel line right here. So we have, so this is 0.86, 88. So we can assume this is 0. So we can predict that this is the value will be specific volume will be 0.80. So we can assume it is 87 cubic meter kilogram of dry air. Now for the enthalpy 2, so drawing the line here, drawing a straight line here, so we can get the value. Okay, so that is 31, 32, 33.5. So we have the value for here, the enthalpy 2, 31, 32, 33. So 33.5 kilojoule per kilogram. So we have now the properties from the psychrometric chart. So we can produce now, we can compute now the cooling load. So we can express our Q, so that will be, so that can be expressed as your Q, volume flow rate, specific volume, multiplied by your enthalpy 1, change enthalpy. Then we have the volume flow rate, which is 1.5 cubic meter per second divided by 0.87 cubic meter kilogram dry air. Then multiply it by the change in enthalpy. So we have 61.5 minus 33.5. So this is the unit of kilojoule per kilogram dry air. So cancel out, which is yung common. So it will be kilogram dry air. So finally we have the value. So we have the value of 42. So this is now kilojoule per second, or this will be kilowatt. So we have here sample problem 4. So air at 32 degrees Celsius dry bulb and 19 degrees wet bulb is cooled and humidified by passing through an air washer in which the water is continuously recirculated. The air leaves the air washer at 20 degrees dry bulb. Determine the moisture added per kilogram of dry air and what is the efficiency of the washer. Okay, so we'll try to establish yung given natin, no? So what are the given? So we have your dry bulb 1, which is 32 degrees Celsius. We have your wet bulb 1, which is 19 degrees Celsius. Okay. Then we have also your dry bulb 2, which is 23 degrees Celsius, and the wet bulb wet bulb 1 and wet bulb 2. Okay, so we have your wet bulb 2 is equal to your wet bulb it's not unequal, so let's erase this one. So wet bulb 2 is unknown. We don't have the properties of the wet bulb 2. Let's see. Let's erase this one. It's not given in the problem. So let's draw this diagram, a schematic diagram for this type of washer. So we have your air entering here. So this will be your point 1. Then we have your air leaving here. So this will become your point 2. Then we're supplying a cooling water cooling water in dito, then we're spraying. Okay, so spraying of cooling water, then we have your collector below, then we have your cooling water out, so recirculated the system. Okay. So unknown, we need to find, so the unknown, so what will be the moisture added per kilogram, the moisture added per kilogram dry air, then B, the air washer efficiency. So we have your solution. So for the amount of moisture added, so we have your change in moisture, that will be moisture at 0.2 minus the moisture at 0.1. Okay, so from the psychrometric chart, so let's try to plot this one. So psychrometric chart, so we're dealing with the dry bulb of 33 degrees, so this is 31, 32, 33. Okay, let's draw a straight line. 31, 32, 33, straight line here. Then, so we have the wet bulb, which is 19 degrees. So this is 25, 25, this is 19, this is 20, this is 15, 16, 17, 18, 19. So what we have here is this intersection. So we have the 19 degrees Celsius here. Okay, so this will be now our 0.1. So let's plot also those lines. This is your 19 degrees Celsius. Okay, then for the dry bulb 2, we have 23. So 30, that will be 21, 22, 23. So here we have 23 going up. Then so we have now the process of cooling and dehumidifying. So we have a constant wet bulb from 0.1, starting from 0.1 to 0.2, no? So we have the values for we need to determine what will be the values of this humidity ratio in order to determine how much is the moisture added the system. Okay. And this one also, we have here the state line. Right here. So this is so we have your now your humidity 1, which is equal to, this is now 0.0081 approximately. Then you have your humidity 2, so this is 10, no? So this can be humidity to 0.00. Oh, sorry. This is 10 only. 0 lang. 0, 1, 12. Makes sense. Paglitan na rin siya. So we have the value. So we can compute how much is the what is the change in moisture. So we can write here. So from psychrometric chart, so we have the values of humidity 1, which is equal to 0.0081, so that will be kilogram per kilogram dry air. Then we have the value of humidity 2, that is 0.012 kilogram per kilogram dry air. So using your equation, so we have now 0.012 minus 0.0081, so kilogram per kilogram dry air. So we have the change in humidity, or say the moisture added. So how much is the moisture being added? So using your calculator, so we have 0.0039 kilogram per kilogram dry air. So for solving now the efficiency of the washer, we have the equation efficiency, so that will be your T2 minus your T1. So this is, now we have your dry bulb as a T1 and your T2 as a dry bulb 2. So we have, this is, sorry, let me correct this one. This is T1 minus your T2 and T1. So this is T3. So it will be T3, or we call it the dew point temperature, dew temp of the apparatus. So plotting that one in the psychrometric chart, so the dew point temperature, it would be the point at this point. So this is 19 degrees. So lowering it down to get the the dew point temperature, so that we have a 19 degrees Celsius. Okay. Then we'll be multiplying to 100% to get the efficiency. So substituting, we have 33 minus 23 degrees Celsius divided by 33 minus your dew point temperature to get the efficiency of the washer. So we have 71.42% efficient yung washer. So next problem, we have how much heat moisture must be added to 28 cubic meter per minute of air at 24 degrees and 40% RH to raise it to 38 degrees dry bulb and 37 degrees wet bulb. Okay, so let's try to plot it in the psychrometric chart. So we have 24 degrees Celsius of air at 40% RH. So here we have, let's draw a line. So that is 24. So it is somewhere here. 24 at this 40% RH. So ito yun. So this is our point 1 now. So this is your point 1 at 40% RH. Then we have also your humidity at this point. I'm gonna plot that one. So the humidity will be this line. So we have your humidity 1. Then the second point is to raise it to a 38 degrees Celsius dry bulb. So I'm gonna plot the line here again. 35, so 36, 37, 38, so this is 39, so this is 38. Going to 37 wet bulb. So intersecting at 37 wet bulb. So that's 7 wet bulb. Okay. So this is 37. 30. So continuing, so one of the problem na encounter natin dito is that you will notice, so we have the temperature of 38 degrees Celsius and dry bulb is 37. So if you're going to look at the psychrometric chart that we have here, so we have 20, 25 and 30. So 30, 31, 32, 33, 34, 35. So that is already beyond doon sa psychrometric chart natin na ginagamit initially. Now, what I'm going to do, I'm going to bring down another psychrometric chart for high temperature applications. So I will also send it in the Google Classroom so that you will have also a copy. So I'm bringing down the psychrometric chart from ASRAE. So it is for high temperature applications starting from 10 degrees to 120 degrees. Okay, so you'll notice barometric pressure 101.325 ppa. Then copyright, that is 1992. So we have here, so that is already reaches to wet bulb natin reaches to 40, 50, 60, 70, 80, 90. Okay, so we have a higher temperatures here. So mostly it is only just up to 50 degrees, but okay, anyway, it is until 100. This is different. We are in for 120 degrees Celsius. So let's plug this in. So I have here now the high temperature psychrometric chart. So let's plot this one. So how much more so let's plot, let's start with the 24 degrees. So ito yun. So we have your 30. So I'm plotting so 20, 21, 2, 4, 6, 8, 10. So we have 2, 24. So 24, I'm going to draw a line 24 at 40% RH. So where is the 40%? So I think this is, we have 60. So this curve, so ito yung 40 na. Ito yung 40% RH. So I'm bringing that here. Okay, so we have now yung 0.1. So this will be our 0.1. So we mark as 0.1 natin. Then the next we have to plot is 38 degrees dry bulb. So 38 degrees, so 2, 4, this one. Okay, this is 38. So 38 to 37. Okay, 38 to 37 dry bulb. So this is already wet bulb 40. So you have 20, 30. 2, 4, 6, 8, 10. So we have 2, 4, 6. So it is somewhere wet bulb. So 30, 2, 34, 35. So 38. So it is in between. It is almost close to saturation. So this is 32, 4, 6, 6, 8, and then you have 40 wet bulb. So this is almost close to saturation curve. So we have here your 0.2. Now let's draw the process. So plotting that one from here going here. Okay, so meron na tayong process niyan. So we have now the arrow to indicate the process flow. Okay, so next we need to determine how much moisture be added to. Okay, so we need to determine how much moisture. So let's cast the line again here towards here to get the moisture. So it's supposed to be that it will be a parallel line here sa gilid. Okay, to get the value of moisture at 0.1. So now let's try to interpret this one. So we have here the humidity, so that is in the units of grams of moisture per kilogram. So we have the value of humidity 1 at 0.1. So that will be so we have 0, 2, 4, 6, this is 2, 2, 4, 6, 8, and then we have your 10. So that is approximated. So we have here the moisture content for 0.1. So that will be 0.0075 kilograms. So take note again. So bakit ako nag 00? Since we have the unit here grams, no? So it's grams per kilogram. So I just only divide that one in order to make it kilogram per kilogram of dry air. Then let's get the enthalpy. So also in this point, traveling. So let's mark it as a color red, no? So we have the enthalpy of, so this is 40 and 40. So by dividing the strip, so hatiin natin, we can get yung ano. So this is 50 sa gitna, in the middle, no? Then we can assume this is 45, and we can assume this is also 43. Okay, so we have the given value. Let's write it here. So from the psychrometric chart, so take note, no class, it should be palagi sa mga calculations ninyo. So kung saan nyo kinuha yung mga value, it should be noted kung saan natin kinuha yung value. Tulad nito, what I'm doing is from psychrometric chart. So at point 1, so let's indicate that one at point 1. So point 1, so that will be 24 degrees Celsius dry bulb, 40% RH. So we have the value of humidity, which is 0.0075. So we have the value of 0.0075. So this is kilogram per kilogram dry air. Sobra na yung zero natin. So let's erase this one. Change this one. So it will be 0.0075. Then our enthalpy at point 1 is 43 kilojoule per kilogram of dry air. Then we need to find the specific volume in order for us to compute the mass flow rate. So specific volume at point 1. So we have the value. So this is the line, wet bulb. So we have this strip, this line for the specific volume. So let's draw the line here. Draw natin linya. So lahat ng strip papunta dito. So we have your specific may mali. Okay. So lahat na okay. So ito yan. So this line. So we have 0.82 this is 0.86. So in between of 0.82, so we can have, so So this is 0.82. We can show this is 0.85. 0.85. So somewhere here, this is a 0.85. 86.82. 83, 84, 85. So it is in 0.85 already, since it is 0.86. So in between, so this is will be 2, 4. So 2, this is 0.82, 0.84, 86, this is 0.85. So we can put it as a 0.85 for the value. So the specific volume ng 0.1 natin, that will be 0.85. So ito yun. So let's draw that line na wala naman. Okay. So this is now your specific volume of 0.85. So mapansin nyo, we have 0.82. This is 0.84 yung line na ito. Then we have 0.86. So in between, we have 0.82. So we have 0.85. So that will be the cubic meter per kilogram dry air. Now at 0.2, so what is the properties at 0.2? That will be 38 degrees. 0.2, 38 degrees. 8 degrees Celsius dry bulb, and we have 37 degrees Celsius wet bulb. So we have the properties of your humidity and also your enthalpy at this point. Okay, so let's try to plot the value to get the, and also plot the lines in order to get the value. So what we have here, drawing the line. Okay, so let's mark it as a red. So this will become now your humidity. So we have the value of your humidity 2, which is equal to, so ilan ba yan? So we have, this is 30. So we have 30 and 40. So we have the humidity that is, this is 40. This is 2, 2, 4, 6, 8, and then we have 50. So this is around 40. That is 40. So that is 41, no? 41.9. So that will be divided by 1000 to make it grams. So we have the relative humidity ratio of 0.0419. So kilogram of bigger than kilogram of dry air. So we have now the value. This is 0.0419 kilogram per kilogram dry air. Now for the enthalpy, we have, so I'm going to draw again a line here. So we have your enthalpy parallel, so this is it. So we have the value of your enthalpy. So we have enthalpy 2 is equal to So this is 140, in the middle is 150, this is 150. So this is 145 kilojoule per kilogram dry air. So that will be 145 kilojoule per kilogram of dry air. So solving for the mass flow rate of the dry air, so we have the mass flow rate M, so divided by your Q divided by the specific volume of 1, where our Q given in the problem, so that will be this one, this 28 cubic meter per minute, then divided by the specific volume at point 1, that will be 0.85 cubic meter per kilogram dry air. And using your calculator, we have 32.94. so this will be kilogram of dry air that will be per minute, dry air per minute. Solving for the heat added, so we have your Q, mass flow rate, times the change in enthalpy from point 2 to point 1. Okay. So we have, this is 32.94 kilogram of dry air per minute, then multiply by the change in enthalpy. We have enthalpy 2, that is 43. So we have this enthalpy 2, so enthalpy 2, we have 145 minus 43, so there will be kilojoule per kilogram of dry air. So cancel out. So we have the value of your Q, so we have 3,359.88. so this is kilojoule per minute. So we have conversion 1 minute to 60 seconds, so divided by 60, so we have 55.998, or let's say this is 56 kilowatt. So we have 56. Now solving for the moisture added, so we have the moisture to determine the equation for the moisture to determine the amount of moisture that will be added. So let's substitute the value. So we have 32.94, it will be kilogram of dry air per minute, then multiply it by the humidity 2, so this is 2, that is 0.0419 minus, that will be 0.0075, 0.0075, so that will be kilogram per kilogram dry air. So cancel out the units, then we have 1.13 kilogram per minute. So in 1 hour, so we have 1 minute, and that will be 60 minutes and 1 hour. So we have times 60, that will be 67.98, let's say 68 kilogram per hour is the moisture added. Very basic lang naman ang calculation, no, class. Hindi naman siya totally complicated and everybody can follow.